Greetings! In this video presentation, I will discuss evaluating functions and how to follow its method of solving. But first, what is functions? We know that functions are based on how we set an input of values and by processing to make an output. We think of it as a machine that makes a raw input turn into a complete product. Now we have this method of evaluating functions. Evaluating functions find the value of f of x or y that corresponds with its given value. Example number 1. Evaluate the functions for a given value of x. We have the given f of x is equals to 2x squared minus 6x plus 9, and its given value is f of x is equals to 3. Solution. We will evaluate the function wherein x is assigned to the value of 3. The first step is to replace every x with 3, or what we call substitution. To explain further, for the f of x is equals to 2x squared minus 6x plus 9, it will undergo on a process of substitution, as the value of f of x is equals to 3 means that we have to substitute the x with 3. So, f of x is equals to 2x squared minus 6x plus 9 will become f of 3 is equals to 2 times 3 squared minus 6 times 3 plus 9. Now we can solve it properly. F of 3 is equals to 2 times 3 squared minus 6 times 3 plus 9. Solve 3 squared and then multiply 6 by 3. F of 3 is equals to 2 times 9 minus 18 plus 9. Multiply 2 by 9. F of 3 is equals to 18 minus 18 plus 9. We then simply subtract 18 with 18. F of 3 is equals to 9 is the final answer, and that means that the function of the value of 3 is 9. It is a simple method of substitution that we can easily understand. Now, let's proceed to the second example. Example number 2. Evaluate the function for a given value of x. We have the given f of x is equals to 4x plus 5. And now we get a different value. And today, we are using polynomials. Yes, we can evaluate functions with other polynomials. And for this value, we have f of x is equals to 2x plus 4, a form of a binomial. And just like what we discussed in the first example, we substitute or replace x with a given value. That means replacing every x with 2x plus 4. Now we begin to solve example number 2. First, we write its given function. F of x is equals to 4x plus 5. Then we replace every x with 2x plus 4. It now becomes f of 2x plus 4 is equals to 4 times 2x plus 4 plus 5. We will now distribute 4 to 2x plus 4, and it will turn into 8x plus 16. Simply add 16 and 5 and we get the sum of 21. Now we have f of 2x plus 4 is equals to 8x plus 21. Now we transpose the following solution. We will transfer 8x to the other side of the equal sign. Now we have negative 8x is equals to 21. And we divide both sides by negative 8, which means we will cross out negative 8, leaving us with x is equals to negative 21 over 8. Since it's an improper fraction, we will convert it to a mixed fraction. To do that, we will divide negative 21 with 8, thus having the answer negative 2 with a remainder of 5. f of 2x plus 4 is equals to negative 2 and 5/8 is the final answer. In this example, we notice that we distributed a number to a polynomial, then we transposed the solution, using that method to properly solve polynomials in a function. But still, we follow the process of substitution, that what makes the solution as a whole. And now we'll begin to solve the equation. First, write the given. F of x and y is equals to 2x squared minus 4xy plus 8y squared. Substitute both 2 and 6 on its corresponding x and y. We'll now have f of 2 and 6 is equals to 2 times 2 squared minus 4 times 2 times 6 plus 8 times 6 squared. Solve first the squared units, then distribute 4 to 2. Then we'll have f of 2 and 6 is equals to 2 times 4 minus 8 times 6 plus 8 times 36. Go on again with distributing the numbers, then subtract and add it. We have now f of 2 and 6 is equals to 8 minus 48 plus 288. F of 2 and 6 is equals to 248 is the final answer. The function x and y of the value 2 and 6 is 248. Here we see in the third example that it has a different given function, yet we still follow the simple method of substitution on their corresponding value. Then we progress through distribution and then simplifying the evaluation. Example 4. Evaluate the function for a given value of x. In this example, we will evaluate the given function with square roots. The given is f of x is equals to square root x minus 76. Then the value is f of x is equals to 121. Just like in the previous examples, we will substitute the value to the x. That means the given value 121 will replace x in the given solution. Now we begin to solve the equation. First, write the given function. F of x is equals to square root x minus 76. Then substitute x with 121. Then we'll have f of 121 is equals to square root of 121 minus 76. Since 121 is a perfect square, it will be reduced back to its original square root, which is 11. Then subtract 11 with 76. F of 221 is equals to negative 65 is the final answer, which means that the function of the given f of x is equals to square root x minus 76 is negative 65. It is a simple solution that requires the root of the function that makes up the final answer. However, if the given value is not a perfect square, then that means there is no real solution given. Example 5. Evaluate the functions for a given value of x. Now we will evaluate the given function with fractions as its value. We have f of x is equals to 3x plus 7, and for the value it is f of x is equals to 3/5. Remember to replace x with 3/5. Now we begin solving the equation. First, write the given function. F of x is equals to 3x minus 7. Substitute x with 3/5. So we'll now have f of 3/5 is equals to 3 times 3/5 minus 7. We will simplify the numbers by multiplying the numerator by 3. Then for the second simplification, we will multiply 7 over 1 with 5/5, which will turn into 35 over 5. We now have f of 3/5 is equals to 9 over 5 minus 35 over 5. Then, subtract 9 with 35. Now, we have the answer. F of 3/5 is equals to negative 26 over 5. Since it's an improper fraction, we will convert it into mixed fraction. To do that, we will divide negative 26 with 5, thus having the answer of 5 with a remainder of 1, leading us with the final answer of f of 3/5 is equals to negative 5 and 1/5. Solving in fraction requires both denominators to be the same in order to properly solve the equation. If the last solution is an improper fraction, proceed to convert it to a mixed fraction for the overall solution. It is possible. Evaluating functions is easy if you follow the method. Remember well to study more about evaluating functions. This is Group 9 and thank you for watching the video presentation.